In 2011, the European Union first expressed a wish to create a series of clear guidelines on energy saving and energy performance in buildings of cultural interest, given their special characteristics. With this in mind, the European Standard EN 16883, Guidelines for Improving the Energy Performance of Historic Buildings, was published in 2018, transposed in Spain as a UNE standard. However, this standard needs to be complemented with practical issues to undertake energy refurbishment, which is the exact goal of the Renopath 2 project. Renopath 2 is the natural continuation of the two you have at the end, from a previous project called Renopath Energy Rehabilitation of Building of Heritage Interest that ran between 2010 and 2012, and from which a methodology was deduced, a guide with which to guide what actions to improve energy efficiency were made in these types of buildings. Renopath 2 has analysed 7 buildings in total, with 4 in Spain and 3 in Portugal. In Spain, they have been the Collegiate House of Villa García de Campos in the province of Valladolid, the Episcopal Palace of Astorga in the town of León, the Moctezuma Palace or Los Cornejo House in Ciudad Rodrigo, and the Castle of La Mota, also here in the province of Valladolid. On the Portuguese side has been the fortress in the town of Almeida, Portugal, the Abade de Basal House Museum in Bragança, and the Cathedral of Vila Real. The Renopath methodology sets down an innovative working method that pinpoints and quantifies the most appropriate energy performance measures to be applied in each building. Given the cultural values of these buildings, non-intrusive measurement techniques are applied in their appraisal and simulation tools are used to assess their impact. This methodology consists of 3 key phases, the first of which is to create an initial energy model to be studied. This appraisal leads to geometric characterization, for example, making a virtual copy that is as realistic as possible of the building on a computer in order to perform simulations and tests. There is also an appraisal of the facilities and energy consumption. Utility bills are analysed, the buildings are visited, the operation of the building is studied, its appropriateness is considered, and so on. The second phase features a study on how we could or would propose improvements for each of the buildings in relation to the appraisal. Thirdly, these improvements are simulated to see the real impact they would have if they were applied in the future. In order to carry out the energy analysis of the various cases, each property must be visited and documented. Within this planning phase, data is collected on the energy consumed to meet the needs of thermal comfort and lighting. This is in addition to the other more general data such as hours of use, type of use, and energy billing, which help us to establish the demand curves and the energy modulation of each case. According to the procedure to follow, 2 important actions must be carried out: inspection and evaluation. First of all, the inspection groups together information on the various parts of the building, the description of the cultural interest, the intentions of its owner, and the conservation opportunities available for the building. The evaluation then analyzes the use of the building, structural documentation, energy performance, and the overall quality of the interiors. Both processes give a better understanding of the operation of the building and provide data to create a more complete analysis. In all 7 pilot buildings, there has to be an improvement with regard to envelopes in windows, doors, all this type of access, or places where heat loss is apparent, and where energy performance must be optimized. In most cases, reliable information is not available, either on a construction level or in terms of facilities, materials used, thermal characteristics, etc. To solve these issues, the Renovation methodology recommends the combination of non-intrusive techniques to obtain this information, such as 3D digitization, infrared measurement techniques, and thermal flowmetry. To complement the appraisal of the envelope, the energy installations must be evaluated, which requires combining information from generic patterns of equipment performance with the data provided by manufacturers, without forgetting the information provided by the managers of each building. Laser scanning, or three-dimensional photogrammetry, was used to create a virtual replica of the building. This is contrasted to see how one technique or another would work. The models resulting from these photographs or from the point clouds provide a laser scan showing how we can appropriately model the building so that it can be usable, especially with regard to the new BIM standards. And, more specifically, with regard to the BIM application for cultural heritage, known as HBIM, which is very different, just as heritage is from construction. Thermal flowmetry was used to appraise the heat transfer through the walls of these buildings. Thermography and measurement of what is called the reflectivity index is a parameter that gives us laser scanning, which is directly related to the moisture content of the wall on which we are doing the sweep. With that, what we achieve is, before the humidities appear and before they are visible to the naked eye, we can see where they are prone or where they may appear, to do preventative maintenance rather than corrective maintenance, which is the usual one that is done in all places. The key goal is to save time and money. The evaluation of the current energy use of the building provides a reference point for detecting the need for measures to improve its performance. In the Renovation methodology, this evaluation is carried out by creating a complete energy model of the building and its dynamic simulation by means of internationally renowned software. This determines the foreseeable evolution in time of the performance of the building. Here at Cartif, we developed all these non-intrusive techniques, particularly the issue of adapting different plans and different models to the BIM standard. The whole issue of using the reflectivity index was rather innovative and has been the subject of various major publications on a European level. What's more, we can develop certain specific sensors for measurements of temperature, humidity, and comfort conditions that combine energy performance with preventative conservation in heritage buildings. The European standard states the need to prepare a complete list of possible measurements to be implemented. According to the Renovation methodology, the list could be prepared by analysing the existing commercial solutions and identifying successful cases of application in heritage buildings. For this, it is useful to have a database with the various systems.
Renovation
is geared towards making applied technologies viable and seeing how useful they are for simulations in another equivalent building, with the knowledge that the initial tests can be implemented on a corresponding site. For instance, if a castle has been studied, such as the castle of La Mota, this can be used at another castle with a similar use to underline the proposed measures, as long as the issues are the same and can be extrapolated and generalized to a certain extent. Projects to improve the energy performance of buildings of historical and cultural interest require special management and monitoring during the implementation phase. Renovation 2 set out to establish a pre-standard on energy performance in heritage buildings. This pre-standard, which is going to be converted or has become a standard in at least 2 countries covered by the project, Spain and Portugal, lays down the groundwork for a Europe-wide standard published by the CEN, European Committee for Standardization. Once these standardizations have been achieved at a simulation level, we must also achieve equivalent standardization in terms of projects, but this will be in the future.